Now, dear students, we are going to discuss about intersecting lines, parallel lines, and transversal. So, two lines are crossing through one point, then they are called intersecting lines. And the point at which, here it is P, the point at which the lines meet, it is called point of intersection. So here this is a line L and this is a line M. Here L and M are intersecting lines. With the point of intersection P. Did you understand? Next, now parallel lines. It is just opposite concept to the previous intersecting lines. Parallel lines. The lines which are not intersecting lines, which are not means non-intersecting lines. Non-intersecting lines are said to be parallel lines. Non-intersecting lines are said to be parallel lines. So here, see the diagram. These lines will never intersect, though produced indefinitely, they never intersect. Okay, so that these are parallel lines here. So here the lines L and M are parallel. We denote like L is parallel to M. Understood? Next, transversal line. Transversal line means, or simply transversal you can say. Transversal means if a line is intersecting two parallel lines or two intersecting lines, okay, is known as transversal line. See, here these are two intersecting lines. When they produced, okay, they will meet at some place. So here clearly these are intersecting lines, and here there is a line which is intersecting these both intersecting lines L and M. So these L and M are intersecting lines, and this line N is intersecting both these intersecting lines at P and Q. So this line N is called transversal. Okay, so if a line intersect two straight lines, whether they may be parallel or intersecting lines. So if a line intersect two straight lines, then that line is said to be transversal. Are you following? So that has to intersect the two lines. The two lines may be parallel or intersecting lines, no matter. But this line has to intersect the two lines. So here L and M are two intersecting lines, and the line N is intersecting these two lines at P and Q, then N is called transversal. Now see the another example. Here in the second case I am taking parallel lines, okay, and this is a line which is intersecting the parallel lines at two different points, which is N. So in this case also this line N is called transversal line. So in either cases the line N is called transversal line. Now if a line intersects two lines, okay, it is known as transversal line. So with respect to transversal line and the given two lines, how many angles we can see, you please observe these diagrams. See how many angles you can get between, okay, two straight lines and a transversal. So between two straight lines and transversal, how many angles we'll see? See here, angle 1, angle 2. This is angle 3, angle 4. This is a point P. This is angle 5, angle 6, angle 7, this is angle 8. So here also same situation will arise. So totally we get 8 angles, okay, when a transversal intersect two straight lines, totally 8 angles will form. 1, 2, 3, 4, 5, 6, 7, 8. Right? Now, the 8 angles that have formed between the transversal and the lines have in them, okay, we have some particular pairs of angles, okay, with particular names. Okay, let us see, okay, what are the names and in which case those are called so and so angles. Okay, let us see all those points. Now first coming to the point, you see the same diagram. First coming to the points, corresponding angles. So a pair of angles is said to be corresponding angles. Number 1, they should be on same side of transversal. Please do understand, they should be same side of transversal. Number 2, one is interior and one is exterior. So they should be same side of the transversal, and one should be interior angle and another should be exterior angle. In this case, they are said to be, okay, they are said to form a pair of corresponding angles. So here let us check what are those pairs of corresponding angles. Let us check. Okay, here angle 1, angle 5, you can see, okay, see they are on the same side. And one is interior, angle 5 is interior, angle 1 is exterior. So the angle 1, angle 5, okay, this pair is, okay, one pair of corresponding angles. Okay, next another pair, angle 3, angle 8. So please see that, because they are on the same side of the transversal and one is interior and one is exterior. So angle 3, angle 8 is another pair of transversal angles. Another pair of corresponding angles. Are you following? Next, coming to this side, so angle 2 and angle 6, the third pair of corresponding angles. Are you following? They are on the same side, one is interior, one is exterior. And next, angle 4, angle 7, another pair of corresponding angles. So totally you can see, okay, that 4 pairs of corresponding angles you can see when the transversal intersect two straight lines. So next, coming to next definition, interior angles. Okay, interior angles means they are inside angles, exterior means outside angles. So here angle 3, angle 4, angle 5, angle 6, all are interior angles. Angle 1, angle 2, angle 8, angle 7, all are exterior angles. Okay, so that is not specific to write, you can easily understand. Next, coming to the point, alternate interior angles. Alternate interior angles means they should be on either sides of transversal. and both are interior angles. So alternate interior angles means they should be on either sides of transversal, but both should be interior angles. So here see angle 3, angle 6, either sides of transversal, angle 4, angle 5, either sides of transversal, and angle 3, angle 6, okay, both are interior. These also both are interior. So angle 3, angle 6 forms one pair of alternate interior angles, and angle 4, angle 5 forms another pair of alternate interior angles. Understood? So they should be on either sides of transversal, both are interior angles. Next, alternate exterior angles. Alternate exterior angles means they should be either sides of transversal, both are exterior angles. Both are exterior angles. So they should be on either sides of transversal and both are exterior angles. So suppose if you see angle 1, angle 7 forms a pair of Dear students, now we are going to learn some axioms and theorems. First axiom is corresponding angle axiom. What is corresponding angle axiom? That I'm going to read out, okay? Just I'm not writing, just reading. See here, if a transversal intersects two parallel lines, then the corresponding angles are equal. So that is the corresponding angle axiom. See this press diagram. This is a line L, this is line M, this is line N, and already we have discussed there forms 8 angles, okay? So these are the 8 angles, and you pick up the corresponding angles. What do you mean by corresponding angle? Already we have discussed. So they will be on both sides of transversal. One is interior angle and one is exterior angle. Okay, so then angle 1 and angle 5 are corresponding angles, and then these are equal. These are equal according to corresponding angle axiom. But here these are equal only these lines are parallel. If a transversal is intersecting a pair of parallel lines, if a transversal is intersecting a pair of parallel lines only, the corresponding angle axiom is applicable. So angle 1 is equal angle 5. Both are same side of the transversal, one is interior and one is exterior. So angle 1, angle 5, angle 4, angle 8, these two are equal. So this is next, angle 2 is equal angle 6. Are you following? Next, angle 3 is equal angle 7. So like this the corresponding angles are equal. This is an axiom. Axiom means it is evidently true, need not to prove that. So you can take them as granted. So if a straight line is, if a transversal is intersecting a pair of parallel lines, then the corresponding angles so formed between them are equal. Next, now we are going to discuss one theorem. This is not axiom, this is theorem. The theorem is if a straight line is intersecting a pair of parallel lines, or if a transversal is intersecting a pair of parallel lines, then okay, alternate interior angles are equal. This is the theorem. If a straight line is intersecting a pair of parallel lines, then the alternate interior angles are equal. That is a theorem statement. Just I am reading, I am not writing to save some time. So what is given? L is parallel to M and N is transversal. What is required to prove? The alternate interior angles are equal. Angle 4 is equal to angle 6. Angle 3 is equal to angle 5. This is required to prove. Now proof. See dear students, angle 1 is equal to angle 3. Why? Vertically opposite angles. And angle 1 is equal to angle 5. Why? Because vertically opposite angles. Are you following? Now angle 1 equal to angle 1. So what would be equal? Angle 3 equal to angle 5. So this one is proved. First part is proved. Similarly, we can prove the second part. Similarly, the second part can be proved. Did you understand? The students, our next theorem is, if a transversal intersect a pair of parallel lines, then the co-interior angles are supplementary. Co-interior means both are interior angles and both are on the same side of the transversal. See, both are interior, both are on the same side of transversal. So angle 4, angle 5 are co-interior. Angle 3, angle 6 are co-interior. Understood? Co-interior means both are interior angles and both are on the same side of transversal. So here what is given? L is parallel to M and N is transversal. What is required to prove? Alternate, the co-interior angles are supplementary. So angle 4 plus angle 5, we need to prove that it is 180. Supplementary means 180. And then we need to prove the next co-interior angle pair, that is angle 3 plus angle 6 is equal to 180. So now proof follows. Okay. Did you understand RTP and given? So now what is proof? You see. Proof. Angle 4 plus angle 3 is 180 because linear pair. But angle 3 is equal to angle 5 because alternate interior angles. So now if you replace this angle 3 with angle 5, so angle 4 plus angle 5 is 180. So co-interior angles are supplementary. We have proved. Similarly, you can prove the next one.